Similarity is a way of expressing concentration of solutions. So it's showing how many moles of solute in liters of the solution. The equation we are going to use, molarity is equal to moles over liter. The volume we are substituting is always must be in liter. Okay, and a mole is the number of moles and molarity is capital M. So the first question, calculate the molarity of a solution contains 2.20 moles of sodium hydroxide in 100 ml. So read the question. It is asking for molarity, which is capital M, and you have given the moles there, and there is a volume given, but volume is not in liters. You have to convert that into liters. Remember, 1 liter is equal to 1000 ml. So what we are going to do, you have to divide this with 1000. So basically this is 100. You will divide with 1000, moving the decimal 3 places. So that will be, volume will be 0.100 liter. And mole is equal to 2.20 mole. Substitute molarity is equal to 2.20 mole divided by 0.100 liter and find the answer. So you have to divide 2.20 divided by 0.1. So that will be what? It will be 22 molar. And this is the answer for that. Okay, second question. This time you are going to find the volume. And it says 2.5 moles. Moles are given. And volume. Okay, you are going to find the 2.4 moles in 3 molar solution. Change that. So you have molarity given and you are going to find the volume. Okay, just substitute equation. Molarity is equal to moles over liter. Molarity is 3 mole and moles is 2.5 mole, and you are going to find the liter. And calculation part, those who don't know the algebra, liters in the bottom, you are dividing. So basically you are swapping this one. So liter will be equal to 2.5 divided by 3. So you are dividing 2.5 with 3, which is 0.83. Since it is lowest sig fig, there is only one sig fig, so I will write it is 0.8 liter. Are you done?
Yeah.
Okay, yeah, you can go. So now next question, you are going to find the mole. This time you have volume given and you have molarity given. Okay, again same thing. We'll substitute in the equation. Molarity is equal to moles over liter. Mole is not given. We have molarity, so we'll write 3.5 molarity is equal to moles is unknown. You can put x variable, and 200 ml. Remember, 200 ml will be 0.2 liters. I will keep the sig fig 0.200. Okay, so now variable is on the top. That means you will multiply these two numbers. So mole is equal to 3.5 times 0.2. Have a good weekend.
You too.
Thank you. 2. So which is 3.5 times 0.2. It is what? 0.7, and I will keep 2 sig fig, which is 0.70 mole, because this 0 is not, leading zeros are not significant. So those are the direct question. But sometimes the question will be one step further. It is asking, calculate the mass of sodium carbonate in 2000 milliliter of a 3 molar solution. So that will be 2 step. Okay, first you have to write the formula for sodium carbonate, which is Na2CO3, and you need the molar mass. Keep it that on the side. So molarity is equal to moles over liter. Okay, and you have molarity given, which is 3 molar, and we don't know the moles, so write moles, and volume is 2000, so which will be divided with 1000 will be 2 liter. Okay, so multiply these two numbers. So molarity will be equal, moles is equal to 3 times 2, which will be 6 mole. So 6 moles of sodium carbonate. Okay, now we have to start a T chart. 6 moles of sodium carbonate. And we know that 1 mole of sodium carbonate is equal to how much gram? This is a gram per mole. That's a mass per mole. So it is 105.99 gram of sodium carbonate. Okay, that is a T chart question. Now we will do the same thing when we do the dimensional analysis. Okay, so moles of moles and cancel, and you will get this answer. So you are basically multiplying 6 times 105.9, and you will get the answer in gram. So it is 105.9 times 6. So it is 635. So you will write 635.4 gram, or since we are rounding to 1/6, you can round that to 600 gram sodium carbonate. So that is about the molarity.